In this example, we want to determine the mobility of a mechanism. The mobility of or degree of the freedom of a mechanism is a number of the independent inputs or coordinates which is required to precisely position all the links of a mechanism with respect to the ground or the frame. In order to determine the mobility of the linkage or a mechanism, the first step is to identify the frame or the ground. The frame or the ground is the link which is stationary versus the other links. In this example, as we can see, this is the ground which is basically connecting by a pin joint and a link. We have a ground here, that slider moving on that, and also these 2 points are pinned down on the ground or the frame. Remember that always we are going to count the frame as a link 1. The second step is to identify all other links. As you remember, a link is a rigid body that possesses at least 2 nodes which allow the link to be attached to other links in order to transmit motion and forces. Link 1 is a frame, as we mentioned. This is link 2, which is a slider. Link 3, link 4, link 5, and you can see that this link has more than 2 nodes. It has 3 nodes. Link 6, link 7, and link 8. So the total number of the links are 8. The next step is to determine the joints. A joint, or also called kinematic pair, is a movable connection between links and allows a relative motion between the links. We have 2 types of the joints. We have full joints, which the joint has only 1 degree of the freedom, and we have half joints, which the joint has more than 1 degree of the freedom. Joint 1 here is a pin joint between the slider and the link. Joint 2 also is a full joint. Joint 3 is a pin down of the link to the ground, is a full joint. Joint 4, joint 5, another pin down of the link to the ground. Here on this joint, as we can see, this joint connecting 3 different links to each other. In such case, we are going to count the number of the joints as the number of the links minus 1. Here we have 3 different nodes, 3 different links, and this joint is connecting them. So we are going to count this joint as joint 6 and 7. Joint number 8, and finally joint number 9, and finally joint number 10, which is a sliding joint, and it is a full joint. So the total number of the full joints in this mechanism is 10, and we do not have any half joints here. The next step is to determine the mobility of the mechanism. Using the Grubler formula, we know that the number of the mobility or the degree of the freedom of the mechanism is equal to 3 times of the L minus 1, which L stands for the number of the links, minus 2 times of the J1, which J1 stands for the full joints, and minus J2, which is the number of the half joints. In this mechanism, we have 8 basically links and 10 full joints, so the mobility of the mechanism is 1. In the other meaning, it means that we need only 1 independent input to control this mechanism or determine precisely the position of other links.